Hey everybody, this is Mrs. Costello. I'm going to be doing day 4. We're going to be doing some special factoring patterns. So some of these might be some shortcuts. Some of these hopefully are a review from Algebra 1. Let's start off with a couple review problems. So I'm going to go ahead and I think it might be a good idea for you to check and see how you're doing on these. Pause your video and do these yourself. And then when you unpause, you're going to see my work. So go ahead and pause your video now. So here's my work on that review problem, or those review problems. Number 2 should definitely be doable because it was what we did on day 3. Number 1, we might have to go revisit that because there's some special factoring patterns in here that we might need to go over. So, if you have questions, you can ask your teacher, you can ask me, but I think that one should be pretty doable. It might be a little bit clearer after I'm done with the notes. So we have 3 different factoring patterns. You might have seen these in Algebra 1. The first one that we have is a difference of squares. Now you guys are used to this because we had to do a lot of conjugate work in our last unit. You understand what makes the middle disappear. The middle disappears if you have the same thing, like you have a minus b and then a plus b, right? You have the same thing here and here, okay? The same number here and here, but then you have a difference in your sign, right? You have a negative and then a positive. So that's where I get that special factoring pattern. So when I see 2 things like this, the first thing I need to check for is, are they perfect squares? The second one we have, second and third, because they kind of go together, are the perfect square trinomials. So what happens is the first and the third term are perfect squares, which is what you see right there. Then the middle is just 2 times whatever the square root of those guys are. I realize this one is kind of a hard one to use a shortcut on, so in my opinion, if you don't use the shortcut, it's okay. I know your other teachers might feel differently, just kind of check with them. But this one always factors down to a plus b times a plus b, like the same thing times itself. Okay. You may also write that as a plus b squared because it is the same thing twice. Now the perfect square below it is the exact same as the first one, we just have a minus sign instead. So I'm going to write these ones out as a minus b times a minus b, or a minus b squared. Now again, I see these as more like tools for you to use. If you want to use them, that's great. I'm going to do examples where I use these. So if you want to use them, cool. If you don't want to use them, that's okay too. So number 1, there are 2 things on number 1, so I am going to check for perfect squares. So x squared, right, is x times x. Negative 25 is, I always put the negative right there because it helps me remember that one parenthesis needs a negative. So it's technically negative 5 times negative 5. Okay. Do I have perfect squares? Yes. So I know I can use that difference of squares. X minus 5 times x plus 5. Okay. Become really familiar with these. These are going to be very important. Number 2 has 3 things. So what we're going to do is we are going to check for perfect squares on the 2 ends. So m squared is m times m. Cool. And then 121 is 11 times 11. Now the middle should be 2 times each of these. So 2 times 11m. Is that 22m? Yes, it is. I know we have a minus here. So I'm going to have m minus 11 times m minus 11, or m minus 11 squared. Again, this is me using my perfect square rules. If you want to use the x again, you totally can. I'm not saying you can't. All right, cool. Why don't you go ahead and pause your video and do 3 and 4. When you unpause your video, you're going to see my work. So pause your video now. So here's my work on 3 and 4. Okay, 3 was the difference of squares, so you should have just gotten it down to 90 minus 8, 90 plus 8. And then 4 was a perfect square trinomial, so I had a perfect square in the front and in the back, and then the middle was the two of them put together times 2. So again, if you use the x factor, that's totally fine. If you didn't, that's also okay. Number 5. Number 5 is another one kind of like number 3. So if we felt pretty good on number 3, we're going to be okay on number 5. Okay. Number 5, I have 9x squared. So 9x squared is just 3x times 3x. And then negative 25 is negative 5 times 5. So I do have perfect squares, so I can go ahead and put each of these in parentheses. So each one gets a 3x. I don't think I was very clear about that earlier, so I apologize. And then each one gets a 5. This one's going to get a minus 5. This one's going to get a plus 5. It's easy. It's factored. We're good. 6. Now, normally when I'd see something like this, I'd go, okay, can I take anything out? I can't. What I can do is I can check for perfect squares on the first and the last. So 25d squared is 5d times 5d. 121 is 11 times 11. And then I have my middle. Remember, my middle should be 2 times my 2 factors, which is 11 times 5d, which is 55d. Yes, 110 is 2 times 55d, so I'm good. So this is a perfect square trinomial. I have a minus sign, so I know I'm going to have a minus sign in my parentheses. So each one gets a 5d. Each one gets a positive, or not a positive, my bad, a negative 11. Negative 11. Or you can always write it as 5d minus 11 squared. Up to you. So in the past, in Algebra 1, we would be like, we can't do this because there's no difference of squares. Now, in Algebra 2, you still have to check for perfect squares because if you have a plus sign right this, you have to use imaginary numbers. So 4x squared is 2x times 2x, okay? This is going to be an I. Okay, with your, you're still doing difference of squares, but you are going to attach an I to whatever the last one is. And the last one, 36, is 6 times 6. So here's what, and I know this looks kind of funky, so if you need help on this, no worries. Each one's going to get a 2x. 2x here, 2x here. Each one is going to get a 6, 6 and 6. And each one's going to get an I right next to the 6. Now, each one also gets opposite signs, so a minus here and a plus here, or flip-flopped, it does not matter. You are good to go on that. Again, in Algebra 2 Honors, we're kind of stepping some things up. So yes, d squared is a perfect square. Negative 12 is not, okay? But we understand how, like when we do the conjugate, you're getting rid of a radical. We're thinking the opposite in this one. You have to put the radical back in. So technically, this is going to be radical 12 times radical 12. You can still use your difference of squares. You just have to use it with a radical now. Okay. So each parenthesis is going to get a d. And now each one is also going to get a radical 12. With opposite signs. Now, if you're like, wait a second, how did that work? Like, think about the conjugate, right? Like, if I did the conjugate, and I teach it with the shortcut. So if I did my firsts times each other, I'd get d squared. And then if I did my lasts times each other, I would get negative 12, which is exactly what I started with at the top. So it's kind of like reverse conjugate-ing. You have to put the radical back in instead. So I'm going to erase this because this is just me showing you how it works. And then this is going to be my answer. Now the rest of the notes is a bunch of factoring. It wants you to find the roots of the following, which means I'm pretty much solving, I'm factoring and then solving. They all have equal signs. So number 9, I need to make my own 0 because I don't have a 0. So I'm gonna do minus 9x on each side. So I have x squared minus 9x plus 18 equals 0. Then I'm going to factor. Okay, this is an easy trinomial, so if you have to set up your x, cool, do it. My special is going to be 18. My middle is negative 9. So I know my two factors are negative 6 and negative 3. So it's an easy, so I can go straight to parentheses. So x minus 6 and x minus 3. Remember that each parenthesis is a solution. It's really easy to see some of these zeros. So like this one's going to be a positive 6, and then this one's going to be a positive 3, right? Pretty easy, hopefully. Number 10 is a hard trinomial. Okay, so we're going to factor like we did yesterday. So if we're doing a hard trinomial, remember that you have to multiply the first times the last, then you have to plug back into the middle. So first times last is my special, so 6 goes on top, negative 5 goes on the bottom. So my factors, if I need a positive 5 or a positive 6 and a negative 5, are going to be negative 3 and negative 2. That's going to go back into the middle. So 2x squared is good. Then I'm going to plug in my factors. Negative 2x minus 3x plus 3 equals 0. I have 4 things, so I'm going to go ahead and group them and take out what they have in common. So for 2x squared and negative 2x, I can take out a 2x. And I have x minus 2 left. And then for negative 3x plus 3, I can take out a negative 3. And I have x minus 2 left. My goal is to get matching here, which is good. I have that. So x minus 2, good. And then my other one, 2x minus 3. The outsides go in the other one. Matching goes in one, outsides go in the other. Now, I do have to solve, and I actually might need to do some work on this one. Because this 0, x minus 2, is really easy to see. It's just going to be x equals 2. If you can't see the 0 right here, do some work. It's okay if you have to add 3 and solve for x if you can't see it easily. 2x equals 3, divide by 2. So my other solution is 3 over 2. So x is going to equal 2, and x is going to equal 3 over 2. Ooh, I messed up. My bad. Hold on. These should be 1s. Sorry, everybody. Sorry. These should be 1s. So then that should be a 1. My bad. My bad. I was looking at my notes and I was like, I did that wrong. Sorry. Number 11 is one of those funky ones like I went over because now we're in Algebra 2. So yes, I have a plus sign, which means I'm going to have some i's in there with my difference of squares. So 4x squared, actually, we can take out a 4 because both of those can be divided by 4. So 4 times x squared plus 9 equals 0. Now that's going to be my I. There we go. And then I'm going to check for difference of squares, or for perfect squares. So x squared is x times x, and then 9 is 3 times 3. You just have to stick that I in there, okay? So, if you factor it, right, I'm going to have x plus 3i times x minus 3i, because it is still technically difference of squares. Now, the 4 does not matter for my solution, okay? This does. Now, treat this like this 3i. I don't want you to think too much into it. If you just put a negative 3i in there, you're going to get a 0. Same thing with this guy. If you just put in a positive 3i, you're going to get a 0. Okay, so don't treat the i's any different when you're finding your solutions. That's one way of doing it. There's another way of doing it. You can ask me about it. You can ask your teachers about it. You could even try figuring it out yourself as well, okay? Whatever you would like to do. Alrighty. Same thing on this one. Let's move it over. So minus 224x minus 224x. So I have 4x cubed minus 4x squared minus 224x equals 0. That's a ton of numbers. So when there's three things like this and there's a cubed, that's my tell that I need to take something out before I even start factoring this. So I'm definitely going to take out an x, and I'm definitely going to check if they can all be divided by 4. So they can. So I'm going to take out a 4x, and then I'm left with x squared minus x minus 56 equals 0. Now this isn't, the inside is an easy trinomial. Because the video is getting kind of long, I'm just going to factor it easy. I'm not going to set up the x. So each one gets an x. Now I have negative 56 and negative x. So I know one of them is going to be negative, one's going to be positive. I also know 8 times 7 makes 56. And if I put the 8 as negative and the 7 is positive, that's gonna work out. So for my zeros, there's one here. This one is always the easy one. It's always going to be x equals 0. Because if you plug a 0 in, it's going to get multiplied by 4 and be a 0. So anytime x is like by itself like that, you have a 0. This one's going to be x equals 8. And then this one's going to be x equals negative 7. So I am going to have 3 different zeros on this one right here. $13 is one of our perfect square ones. You are more than welcome to factor it using x if you want to. But I'm always going to check for perfect squares, because if I have a shortcut, I'm going to use it. So this is 2m times 2m, and then 25 is 5 times 5. Okay, so I've got perfect squares. I know I'm going to have a minus, and I know that this middle part is going to be 2 times these guys together, which is 10m. Awesome, it works. So because it works, I can go ahead and go straight to parentheses. So each one gets a 2m. Each one gets a minus 5, because my sign is minus. Now, you technically only have 1 0 because these guys are the exact same. So you really only have to do the math on one of them. I'm going to do the math on the one on the right because I already see the equals 0 right here. So I'm going to add 5 on each side. So I get 2m equals 5. I'm going to divide by 2. And I'm going to get m equals 5 over 2. Okay, this guy. You are more than welcome to move the 50 over, make your own 0, and solve by factoring. Or, remember last unit, we could totally get the x squared by itself and then solve using square roots. I'm going to use a space pen for this one because I really like this one. So, if I'm getting the x squared by itself, I'm going to divide by 2 on both sides. So I get x squared equals 50 divided by 2 is 25. Okay. Now to get the x squared, remember we're going to square root it. So x is going to be plus or minus 5. Okay. So sometimes you have options like this. We're going to talk about this a little bit more in this unit where like you could do this either way. So just so you know, you have those options. Number 15. Do not freak out just because there's 4 things, okay? When there's 4 things, we need to group them first, and then we'll start factoring and like see where we go from there, okay? This is kind of a spicy one. We'll see how this goes. So 3y cubed and negative 2y squared. I can take out a y squared. And then I have 3y left minus 2, Okay. Second parenthesis, I have negative 12y plus 8. So I'm definitely going to take out a negative because I want, them to match. So I'm going to take out a negative, and then they can both be divided by 4. So 3y minus 2 equals 0. Matching goes in 1, so 3y minus 2 goes in 1. Y squared minus 4 goes in the other. Okay. Now this y squared minus 4 is why I'm like, oh, this is a spicy one, because you got to keep going. Y squared, y times y. Negative 4 is negative 2 times 2. I had to break out the rainbow pen for it because it's so awesome. So I'm going to have 3 different parentheses right here. So I'm going to have 3y minus 2 times each one. Remember, each parenthesis gets a y. Each one gets a 2. One of them's going to be positive. One of them's going to be negative. I realize why I don't use rainbow pen a whole lot because it's kind of hard to see. Okay. So I have 1, 2, 3 zeros. Okay. This one right here you might have to solve for, but I think some of you guys have pretty good number sense, so you understand you move the 2 over and then divide by 3, so you would get 2 over 3. This one would be 2. This one would be negative 2. So 3 different zeros on that one. That's a tough one. For our last one, I actually would like you to do it. There's 2 different ways to do this one. You can do it using perfect squares, or you can use solving with square roots. I'm going to show both ways after you unpause your video. So pause your video now and finish this one. So this is my work. On the left side, I used my special factoring techniques. On the right side, I solved using square roots. Both ways, I still got, plus or minus 11. Look, here's my plus 11, here's my minus 11. So you have options. If you want to use one way versus the other way, you are totally free to do that. Of course, I'm saying that, and if you don't have me, you might want to check with your teacher, but you've got options. So if you have questions, bring your questions to class. Otherwise, have a good rest of your day.